Do you anyone know this? Yeah, wait, the next one. What's that?
I did my back, but instead I took I said not. I said two. Yeah.
So you took 2 and 1.5.
Yeah, I did it as well. And I did 1.5 and I got 4.5. I used X squared to express 1.5 squared. Who was I doing this with yesterday?
It's 6.25. All right, guys. So
I'm not playing that up for us.
no, we just use the right to see. You could have just used whatever in that small triangle, right? So the two sides there was 2 and 1.5, and then you would have gotten to X. But then your own reason would have been Pythagoras. That's perfectly fine. You just have to use the theorem. What I did was I worked in the big triangle and I got that side, which is 5, and then I halved it. So it just depends on the method that you use, but it's fine. You just use Pythagoras in the small triangle. Are there any questions on that, guys? Yep. All right, I'm going to move down to number 2. I think there was a bit of confusion yesterday. Number 2, you guys are like overthinking it a bit. So, I don't know if my colors are making it more or less confusing, but just quickly, they gave us all of this information. So everything in color I added, obviously, right? No, actually not. Sorry. I tried to like color code because M is the mid. Wait, where am I now? First question was ANPN, right? Now, guys, many of you were trying to find like the length of the sides and to do diagonals and to do all sorts of things. But actually, all you needed to do was you needed to prove that both pairs of opposite sides are parallel, which is actually quite simple to do in all 3 of these questions because they told us that N is the midpoint of AC. M is also the midpoint of AB. So this line, MN, is a line joining the midpoints of 2 sides. So using midpoint theorem, we know that MN is going to have to be parallel to BC, right? Because of midpoint theorem. And that happens all the way around. So if we're looking at M and P, those again are 2 midpoints. So MP is the line joining 2 midpoints. So that MP is going to be parallel to AC. And then what's the last one? This one here. PN or NP, these are also both midpoints. That was all written in the little paragraph at the top, right? They didn't actually fill it in on the diagram. So NP is also a line joining the midpoints of 2 sides. So that means that NP is going to be parallel to AB. And if you had those 3 pairs of parallel lines, you could prove all of those are parallelograms. Yeah.
Now I said R1 is equal to R3, but the one angle in the middle.
Oh, is this an R?
Yeah.
And then okay, yeah.
And then R2 is equal to R4. And then I just said that bisect.
No, so the bisect has to do with the actual length of the diagonal.
Okay.
All right, guys. So you'll see that my solutions for all 3 of these, where you have to prove that they are parallelograms, is basically the same. So for the first one, I'm quickly going to go back up. AMPN. AMPN. Those 2 sides are parallel, right? I put my parallel symbol there. Those 2 sides are parallel because MP is the line joining the midpoints of these 2. All right, so MP is parallel to AN because of midpoint theorem. And then remember, we're looking at this shape here. The other sides of that parallelogram, AN and PN, those are also parallel, also because of midpoint theorem. Okay, so I just put that in one line. So therefore, AMPN is a parallelogram, both pairs opposite sides parallel. Okay, are we all right with that first one? Yes? Yes. Yeah, so you could have said that MP is half of a. Yeah, could have been. Okay, fine. Now the next one, guys, that they wanted us to prove is upon was MNPB. All right, so this shape here at the bottom. Now we had already proved that we I wrote here that we said that in the yes. So we actually already proved that this line is parallel to this line, so we can use it there. We've already stated that. So guys, I did write it again, but you don't have to. Okay, if you already stated that one side is parallel to the other one, you don't have to again, but I just did for the sake of completion. And then MN parallel to BC also because of midpoint theorem, because M and N are both midpoint. Okay, it's a bit confusing because there's so much going on, but yeah, you won't get a question like that in an exam where you have to prove the same thing 3 times, if that makes sense. All right, so hopefully it won't be as confusing. And then for C, we had actually already proved both of these pairs parallel. So you didn't actually have to state this whole first line again. You actually could have just said MPC and is a parallelogram, both pairs opposite sides parallel. We already proved that these 2 pairs are like combinations of the ones that we stated up there already. Yeah.
That half is one part of a line parallel to another. It's automatically true.
Okay, guys, I will post all of this now at the end of today's lesson because this is the last lesson that we have on midpoint theorem. So if you haven't quite copied this down, or if you maybe want to try it again, you can. Let's just quickly look at number 3. Number 3 was different in the sense that they didn't tell us that in and T are the midpoints. We have to prove that. So for number 3, that's what the picture looked like. For 3A, they asked us to prove that N is the midpoint of EQ. So guys, we have to use converse midpoint theorem for that. But remember, converse says that if you have a line going from the midpoint of one side, which we do have, right? M is the midpoint of this side. But then also, if this line is parallel to the second side. Now, they didn't tell us that MN was parallel to QR. But because of those 90-degree angles, do we see that F shape thing, corresponding angle? It's like the example that we did yesterday. So because of corresponding angles being equal, we can say that MN is in fact parallel to QR. So therefore, because of converse midpoint theorem, which is that long distance, N will be the midpoint of EQ. So just that reason is there on the sides of the whole thing. All right, line through midpoint parallel to second side. Yes, Daniel? Usually you don't have to use the construction unless it's approved, but I mean, well, what do you do?
I extended CN or like from C to N. And then I said that, and then I called that point B of Earth. And then I said B order than B Earth is equal to or C, which are like opposite sides. What do I need to prove it there?
You have to prove that first. Yeah, so rather, usually the questions that they ask you won't ever require a construction. Okay, so before you try that. Okay, and then to prove that T is the midpoint of this side, it will be the exact same thing. You just first have to prove that MT is parallel to NQ, but again, we have that those 2 angles are 90 degrees each. So again, we have corresponding angles equal. If we look at that F shape there. So because M is the midpoint of one side and this line is parallel to that one, we know that T is going to be the midpoint of the first. So you're gonna do lots more practice on this stuff now. So hopefully if you struggle with this homework, so no. Yeah, they just said that these 3 points are the midpoint. So you had to use that to prove that all those signs are correct. Because of midpoint. Yeah. So as soon as you have a line joining two midpoints, that line is parallel to the midpoint. Okay, so you have to use that for all three of those. All right, guys, I have a worksheet which is on Google Classroom, but I might have to go print it for you. Do you guys have your phones? Are you able to work on it? Can I go print it? I can go quickly. Let me just put it up on the board. Ma'am, did you have any worksheets? Yes.